So in this problem, you have a skateboarder is moving at a constant speed of 1.75 meters per second when she starts up an incline that causes her to slow down with a constant acceleration of negative 0.20 meters per second squared. How much time passes from when she begins to slow down until she begins to move back down the incline? So let's go ahead and just draw a diagram of what's going on. You have an incline here. We have a skateboarder at the bottom. Let's draw a little skateboard, moving up. There we go. And the skateboarder is moving up this incline. Now the skateboarder starts at the bottom, and it says it starts at, and she starts at with a speed of 1.75 meters per second. And then once she goes up this incline, her speed starts to decrease with a constant acceleration. And the question is asking how much time passes when she begins to slow down until she begins to move back down the incline. In order for her to move back down the incline, she has to reach a speed of 0 meters per second. All right. Once she reaches 0 meters per second, that's when her speed starts to go in the opposite direction, and her velocity, which will be in the negative direction. So let's go ahead and analyze the wording of this just to clarify our givens and unknowns. So skateboard is moving at a constant speed of 1.75 meters per second. So this right here, the unit meters per second, this is my velocity. That gives you my magnitude. So this is my initial velocity that the skateboarder has at the bottom of the incline. And then we now know that it causes her to slow down. So we know she's slowing down with a constant acceleration. So we now know I'm dealing with A of negative 0.20 meters per second squared. So this confirms that's acceleration because I have meters per second square and I have the magnitude. So this here tells you the value of my acceleration. Notice it's negative. How much time passes? So this, how much time passes, is actually asking for my time, and my time is going to be unknown, from when she begins to slow down until she begins to move back down the incline. Now this doesn't tell you directly, but as mentioned earlier, this is trying to refer to her velocity or final velocity to be at 0 meters per second. So I'm going ahead and put all my givens. Initial velocity is given to be positive 1.75 meters per second. I'm going to make the direction, or going uphill, to be positive. Acceleration then is going to be a negative 0.2 meters per second square. That's given here. My time is unknown. And my final velocity, although it doesn't state it directly, it's implied that it's 0 meters per second. So I'll go ahead and decide which kinematic equation I need. So looking at my givens, I know I need initial velocity. All the kinematic equations have initial velocity, so this doesn't help me. The second given is acceleration. I need acceleration in the equation. So automatically I can eliminate this equation because acceleration does not appear anywhere. Acceleration appears here, here, and here for the other three equations. Next, final velocity. Final velocity appears here, so I may have to use that equation. Final velocity does not appear in this equation, so I'll go ahead and eliminate this one. And final velocity appears in this one, so I know I can possibly use the fourth equation. Last, time. I need time to show up. So looking at the last two equations, I see time appears here, so most likely I'm going to use this equation, and time doesn't show up in this one, so I'll go ahead and eliminate this one. So for this problem, I'm going to be using this kinematic equation right here. So now I know which kinematic equation to use. I'm going to use final velocity is equal to initial velocity plus acceleration times time. So let's go ahead and rearrange this equation to make my math easier. I want to go ahead and solve for my unknown, which in this case will be time. So first thing I can do is subtract both sides, initial velocity. This will go ahead and eliminate this, and on this left hand side I'm going to have final velocity minus initial velocity equals to acceleration times time. Now to get time by itself, I have to eliminate the acceleration. So I'll go ahead and divide both sides by a. So divide both sides. The two a's cancel on the right side. So on the right side, I'm just left with t. And on the left-hand side, I'll have final velocity minus initial velocity all over acceleration. And this is my equation that I'll use to solve for time. Now with my equation, final velocity minus initial velocity all over acceleration equals time, I'll go ahead and just plug the values in and solve for it. So final velocity is 0, initial velocity is 1.75, divide that all by acceleration, which turns out to be a negative 0.20, and set all equal to time. Luckily, 0 minus 1.75, that just gives you negative 1.75. I'll go ahead and divide that by a negative 0.20. Remember, you have a negative number divided by a negative number. They both cancel out, or the sign will cancel out, so you'll be left with a positive answer. And dividing 1.75 by 0.2, you should get 8.75 as my time. So remember, time, the unit for time is seconds. So I'm going ahead and rewrite this as 8.75 seconds. Now I'll go ahead and double check my answer. So I got 8.75 seconds. First, you have to ask yourself, is this too small or too big? And for our case, it kind of seems reasonable as long as your answer is not within like 0.01 second and it's not big as maybe 400 seconds, then your answers can be reasonable. And also notice that the sign for time is positive, it's not negative. Time in your case will never be negative, so if you have a negative answer for time, you may want to double check your work. So time is not negative and it seems reasonable. That means that this is our correct answer then.